We have to solve for z in this equation, and remember that I is the unit imaginary number, the square root of -1. If you're familiar with imaginary numbers, recall that -I is the same thing as I cubed, I to the power of 7, I to the power of -1, I to the power of -5, etc. Notice that all of the consecutive exponents have an interval or difference of 4 in between them. The reason that this is possible is because you have to remember that I, like I said earlier, is equal to the square root of -1, I squared is equal to -1, I cubed is equal to I to the 4th power is equal to 1, and then I to the 5th power is equal to the square root of -1. The pattern continues on. Now, let's write the equation down, but we're going to rewrite -I as I to the power of 3 plus 4n, where n is any integer. Next, notice that we have the same base of I on both sides of the equation, so we can set the exponents equal to each other to get 2z plus 2 equals 3 plus 4n. Then, we're going to solve for z by first subtracting 2 on both sides of the equation to end up with 2z equals 1 plus 4n. Lastly, we're going to divide both sides of the equation by 2 to see that z equals 1 plus 4n over 2. Therefore, there's an infinite number of solutions. So one possible solution is when we substitute 1 for n, so 4 times 1 is 4, 4 plus 1 is 5, so 5 over 2 must be one possible solution.